So again, you may want to write these things down because they will be part of your word problem assignment. And they're also going to be on the quiz on Fridays. So the first thing I want to talk about is called a weighted average. It's called a weighted average. And I'm sure you guys are familiar with how to do a regular average. Are you familiar with how to do a weighted average? No? All right, so let me show you, we'll review how to do a regular one, which I'm sure you guys all know how to do, but then I'm gonna kind of apply that to a weighted average. So here's a regular average. If I ask you to average up three numbers, let's say 60, 70, and 80. Now actually, my hope is that if I ask you for the average of these three numbers, you would not need to do any calculations at all. What would be the average? If you got a 60 and then a 70 and then an 80 on something, you would have a 70 average, right? Because you have a 70 and then you got one that's 10 below and 10 above, and you understand that the average is like the middle, right? So that would definitely have an average of 70. But how would you mathematically calculate the average? You add them all up and divide by 3, because that's how many there are. So that's one way to do an average, and that's how most of you guys are used to doing averages. I'm going to show you another way that you can do an average. It's actually the same calculation as this, it just looks a little different. So check this out. This is 1/3 times 60 plus 1/3 times 70 plus 1/3 times 80. Would you agree that that's the same thing that I have right up above? Instead of dividing by 3, I'm multiplying each thing by 1/3, right? Well, we know that division by 3 and multiplication by 3 is the same. Now this is not technically a weighted average, but it's in the same form as a weighted average. The only advantage to doing it this way is that you can really quickly see at a glance that there are 3 items up here, and that each of them is weighted exactly 1/3. So this quiz is worth 1/3 of your grade, this quiz is worth 1/3 of your grade, and that quiz is worth 1/3 of your grade. So the 1/3 that's being multiplied by tells you how much it's worth as a portion of the overall grade. If I wanted to change this, and for example, let's make, let's change these up a little bit. I'm going to make, let's say the first one is worth 1/4 of your overall grade, and the second one was worth 1/4 of your overall grade. And there was only one more. How much of your overall grade would that last one have to be? It would be half, right? Because I got 25%, 25%. That one's going to be worth 50%. Now that's not an average anymore, that's not a regular average because they're not all worth the same thing. Okay, so it's not your standard average, this is called a weighted average. These things that are out in front are our weights. Now it's important that the weights always add up to what? They have to add up to 100%. Now it's always going to be a fraction or a decimal. Okay, but they should always add up to 100% or 1. Right? In this case, we got 1/4 plus 1/4 plus 1/2, which does add up to 1 or 100%. Does that make sense? So that's how a weighted average works. Now, number 2, in the word problem assignment, if you look at number 2, it deals with the weighted average. If you read through that problem, can somebody describe the problem to me? You got what? You guys, you don't have a book out? You need to have a book out. If you don't have a book, then get one. I asked you to do that a second ago. Go get a book. Unless you've got it on your screen, that works too. Get a book. I'm not doing these things for you. It's even problems. Starts on 77. All right. Page 77. I need you to read over problem 2 right now. We're talking about weighted averages, and hopefully you'll find a weighted average somewhere in that problem. Page 77. Does anybody particularly like reading out loud? Would anybody be opposed to reading out loud for us? Are you volunteering? All right. Thank you.
It's 77.
Page 77, number 2.
For the final exam, a student has a test scores of 72, 80, 65, 78, and 60. If the final exam counts as 1/3 of the final grade, what score must the student receive in order to get a final average of 76?
Thank you very much. Okay, so do you see why we're talking about weighted averages? Did you hear in someplace in that problem where something was worth 1/3 of the final grade, right? So what we're going to do is we're going to do a weighted average. We'll have a weight times a value plus another weight times another value, and this is going to equal our final grade. Now you might be thinking, wait, there were 5 different grades listed in that problem. Is that right? There were 5 different grades? All right, so what we're going to do is we're going to kind of break it down just into 2 grades, because we know that the final grade is worth how much? How much is the last test worth? 1/3 of your overall grade. So 1/3 times the test is going to be that portion of your final grade. And if the test is worth 1/3 of your final grade, then what is everything else going to be worth? 2/3, because we got to add up to 1. And this 2/3 is going to be, I'm just going to write the rest. So the test is worth 1/3, the rest is worth 2/3. The rest constitutes those 5 grades that are given there. Now, in order to do this, we're going to need to take those 5 grades and turn them into a single grade. Do you think of any mathematical tool that can be useful in turning a bunch of grades into a single grade? You could take just the straight ahead average of those, right? And that would turn it into a single grade. So that's exactly what you're going to do. This is going to be the average of those 5 grades. Do we know the value that we're going to get on the test, or is that what they're asking us for? No, that's what the question's asking for. So that's where our variable is going to go. Do we know the final grade that the student is shooting for? 76, so we'll put a 76 in that last spot, and then we'll have an equation that we can solve. So I'm going to give you a few seconds to take some quick notes on that, and then we're going to go over the next concept for today. Just like that. I'm not going to write the equation for you.
Oh, okay.
Yeah. I'm not doing these problems for you. I'll give you sort of some examples.
No, I was worried you were going to move on.
No, I am going to move on from it.
No, I mean.
But go ahead and take whatever notes you need to. From this, you should be able to fit your equation. It's going to look very similar to this. You're going to have some variables and some numbers in there, obviously, instead of just words. But that's what your equation will look like. Now, what do I need you to be able to do on Friday on a quiz? If I gave you a list of 3 or 4 grades, and then how much each one was worth in terms of your overall grade, could you find me a weighted average for those 3 or 4 grades? Would you feel comfortable doing it? We'll review that on Thursday. Okay. I know some of you are probably really anxious to get this equation solved, but just put it on hold for a second, make sure you've got a couple notes, and let's move on to our next topic, which deals with percentages, and specifically percent increase and decrease. So I'm going to give you the classic percentage problem and ask you to solve it. I'm going to show you a different way to solve it. Some of you may already understand this way, but I'm going to show you in 2 different ways. So let's start off with, all right, we go to the store, we're going to buy something, $80. I don't know, a pair of shoes, maybe, a watch, a what? A shirt, really nice shirt, a jacket, I don't know, you make the call, but we're going to spend $80 on something. On what? On a cereal? That's an expensive cereal. I bet it better be like a cartload of cereal. But just as we're about to check out, we see this sign that they're just putting up that says, it's 30% off today. Woohoo! Which means we're going to pay less than $80. So my question to you is, either mentally or using your calculator or on paper, could you please find out how much we're going to actually pay for this thing? This costs $80 normally, but today is 30% off. If you can do it in your head, all the better, because this is something that's really useful to be able to do in your head. So find me a price. How much are we going to pay? You got a value?
What? How much are we gonna pay?
I was talking about that.
56.
56? Anybody else got 56? 56? 56? All right, now there's a couple ways to do this. Here, in my experience, this is how most students do it, and this works just fine. A lot of people are thinking $80, okay, it's 30% off, so I'm going to figure out what 30% of that is. So 80 times 30% is a decimal, right? And if you do that, you'll find that this is going to be $24 off. Okay, just a second, please. And then we take 80 and we'd subtract 24, and that would give us 56, which is the correct answer. So that's one way to do it. There's another way that I would prefer you know how to do this. Now, some of you are going to think to yourselves, well, this works for me, why do I need to learn something else? And you just got to trust me on this. There's a really good reason. Number one, it's going to allow you to solve problem 4 on the word problems. 2, we're going to do a whole unit on exponential growth and decay, and it all is based off of this concept. Okay? Does anybody know the other way that we could have come up with 56 more quickly?
Cross products.
Say it again.
Cross products.
I still didn't hear what you said.
Cross products.
Cross components?
Cross products.
Cross products. Yeah, you could do it that way. I think there's an easier way. I think I heard somebody over here say it. What were you going to say? There we go. Instead of taking 80 and multiplying it by 0.3 and figuring out that's 24 and subtracting that from 80, check this out. 80 times 0.70 is 56. I think I talked to a few of you guys last week about this. Okay, now, can somebody explain to me why that works? How does it work? So, good. So 100% minus 30% is 70%. Agreed? If it's 30% off, you're subtracting 30% off. Okay? Whether that's $24 or whether that's 30%. If you're getting 30% off, what percent of the original price are you actually paying for? You're paying for 70% of it. In the long run, most people don't care about the $24. Yeah, it's nice that I just saved $24, but really what people want to know is how much am I going to pay? I don't really care how much the thing is off. I just want to know how much am I going to pay. It's a lot easier mentally to just do one operation, 80 times 0.7 to come up with the final price, than to have to do 2 different operations. 80 times 0.3 is 24. Now you got to hold that in your head and somehow subtract that from 80, and that can get confusing sometimes. So the idea is, if you're ever increasing or decreasing by a percentage, okay, and when would you do this? If you're decreasing something for a sale price, that's one time you would do it. What about tax? Put that way. Oh, okay. Not that one? You know, like a regular calculator? What use that? I'll use your minutes. Sales tax is another one. In sales tax, they're adding on a percentage, right? For actual sale, they're taking off. In fact, let's do an example of sales tax. What if we, okay, it's still 30% off, which we now know is 56. Let's say we also have to pay 8% sales tax. Give me a number that I could multiply 56 by. I don't care what the tax is. I just want to know what the final price is. Give me a single number I could multiply 56 by to figure out what my final price would be after paying my 8% tax.
1.08.
1.08 is correct. Let me see if I can predict your thought process here. You think, since it's 8% being added on, you thought 100% plus another 8% would get us to 108%, and then you turn that into a decimal. That's exactly correct. That's exactly how you could do that. All right, so I'm going to use this same concept. And again, I know some of you may be thinking, oh, I don't need to know how to do it this way. Trust me, you're just going to have to trust me. You absolutely do need to know how to do it this way. Okay, so if you're increasing or decreasing, we're adding and subtracting from 100, and then we're multiplying that number by the original amount. So here's an example that's going to be a little bit closer to what you're going to do in problem number 4. Okay, it's different. I'm not going to do the problem for you, but it's the same principle. Let's say you go out for a meal. All right, so you take your parents out to dinner just to say thanks for being so supportive and praising me and spending all that money on me. You take your parents out for dinner. How much is that going to cost? I guess it depends on where you go. Someone throw out a number. $120. Ooh, you're going out for fancy food. $120. But they're worth it, right? They're your parents. They love you. They take care of you. It's worth it. All right. And let's say it's time to pay the tab, and you're like, "No, sir, I'll take that. Thank you." You know, and you get the receipt, and of course, there's the meal, but then they've also added some tax onto it because that's what happens. So we're going to pay a tax on top of it. Let's say our tax is, I don't know, 6%. I'm going to use something different than is in the problem there. So I'm going to say our tax is 7%. Big difference there, all right? Now, what's my total going to be? What could I do to $120 to figure out what my total is? I can multiply it by one single number. What number would that have to be to raise 120 from its current value up by 7%? 1.07. Nice. Go ahead and put that in your calculators and tell me how much our bill is going to be. $128.40. Sounds reasonable. Okay, so it's a little more expensive. And then, of course, we're also going to tack on a tip, right? We're going to tack on a tip. So we're going to take this $128.40. We're going to tack on a tip. Now, let's be kind to our servers here. Plus, you're trying to impress your parents, right? What percent are we going to get? 50?
No. 20.
Let's settle. 20 is pretty good. 20 is pretty generous, you know.
I'm spitting their food. For a meal
I mean, this is a pretty
It's true.
expensive.
Well, teenagers get a bad rap for tipping sometimes. It's true. It's true. I know that it's not across the board. All right. So again, I don't really care what the tip amount's going to be. You guys know that if you do the credit card thing and you just put the total down, we'll figure out what the tip is. In fact, when they put it, those of you who are servers can correct me if I'm wrong here. Anybody a server here? I'm pretty sure when they put the bill in there, when they put the credit card bill in, all they put in is the total. I don't think they type in what the tip amount is. So if you do the math wrong and you put down more for the total than you were supposed to, then you're actually tipping. It's the total that they care about. So what would the total be here? What would I multiply $128.40 by to get myself? 1.20. And go ahead and tell me what that final value is. What are we actually going to spend out of pocket here? $154.08. That's a pretty expensive meal. But they're worth it, right? Oh, okay. All right. So here's this problem, and your setup is going to be the exact same as this. Obviously, you're going to have some different numbers. Our food cost us $120. Okay, and then we had our tax, and we did a 6%. No, we did a 7%. To accomplish that, we did 1.07, and we added that on, or we multiplied that on. And then we had our tip, and we were feeling especially generous and trying to impress our folks. We tipped 20%. So we multiplied again by 1.20, and that gave us our final bill, or our final out-of-pocket cost, which was $154.08. Okay? Your equation is going to look just like this. You're going to need to figure out where does the variable go. Obviously, this isn't going to be 1.07 and 1.20 because they didn't have a 7% tax or a 20% tip. So adjust those as necessary. I guess my question for you is where's the variable go? What is it that they're asking us for? Are they asking us for how much will the final bill be, or are they asking us for how much do we need to limit our food costs to? So they're asking for this. You're going to need to put your variable over here, and I'll let you guys figure out the rest of the numbers. And that's that. So write down what you need to, or set up that equation. I'm going to do one more quick thing. I talked a longer than I said I would. Hopefully we're getting through a few of these problems. All right, the last one I want to talk about is problem 6. And this is going to be my big hint for problem 6. Let's use a proportion. 6 is just perfectly set up for proportional reasoning. You guys know how proportions work? All right. You know what? I'm going to let you. I'm going to just leave that as my final hint for problem 6. As you move through these, you'll be fine. It's not terribly difficult. Set it up so you've got like water in the first fraction and total in the second fraction. You know, if you do a percent here, do a percent here. If you do an amount here, do an amount here. As long as things match up, top and bottom, left and right, it'll be fine. Show me your setup if you want to before, and I'll tell you if you're doing it correctly. There's a lot of different ways to set up that proportion. Last couple hints. Problem 10. Whatever you do, I'd save it. We're going to spend about 5 minutes tomorrow talking about problem 10. It's the hardest one in the whole assignment. So maybe leave yourself a little block of space there. When you get into some of the later problems, like problem 8 and on, you're going to want to start making tables. A lot of these problems are ones where you're going to end up using a system to solve, so you'll want to make tables. If you need my help setting up a table, I can kind of help you get started with that. Okay? Again, work with a partner, work together on these things, and then compare answers with one another. All right? Good luck. Let me know what questions you have.
Okay.